Fantasy face. Well, it's not the most creative name. Most of my templates are not named creatively. I really want them to be something that you can adjust to your needs and make your own. If you like how the mechanics of all of them are put together, but also to illustrate that under the hood for even stuff that gets used and becomes popular, it's usually pretty simple. This is a refrain you'll hear from me a lot. Let's let this run real quick. So we've got special eyes here. Oh, and blinking gives us a glowing effect. Changes the environment as well. So a couple of things going on here. And part of what I wanted to show, in addition to the fact that it is based on a real effect that happened, in this case, not to make it to market, but was in development with a studio for an animated series, is that there's more than one way to deal with things like eye effects, and there's built-in ways to do it that are very easy. And if you want to kind of add your own stuff to it, there are a couple of gotchas and things to be aware of. So let's dive in here, and as I do with any of the templates, I kind of start up here, go through, mention anything over here we need to be aware of, anything over here we need to be aware of, and then we'll dive into the node graph. So up here in our scene hierarchy, we have standard stuff with the camera, focal distance. Standard lights, didn't mess with those. We do have a face tracker that I've called eyes. And to keep the size down and make things more configurable for individual people, I just made one eye, and then one eye has properties assigned to it that flip its position. So this keeps our file size lower on the effect itself and makes it more configurable for individuals. So we've got something going on with our left eye that we'll look at in the node graph, and the right eye. The face itself has several things going on because of the effects that happen when they blink. We've got a little bit of facial tattoos and some sort of blush or facial coloring there. That's what all of these are. Special stuff happening for the lips, for gloss, for the glow on their face, the retouch, which is kind of comes with when you apply certain face meshes to people, the diamond, the deform, which in Spark is not very pronounced, but in Effect House you will see a much bigger pronouncement of that. Occlusion holder, yeah, so we just want to make sure that this stuff is not colliding and cutting through each other. So there is a base face mesh that keeps all of that rendered out transparently correctly. That's the purpose of these. Eye color, so this is not the eye glow, but the eye color that's automatically applied to you when you are in your daytime scene. And that is done with like built-in nodes. It's a much easier thing to configure, but it has the drawback of using a built-in patch, which may or may not give you the kind of configurability and customization that you're looking for. One for the left, one for the right. LUT holder. LUT in this case is a bit of a misnomer. A lookup table is a way of adjusting the color grading for an image, and this is just a shorthand for saying that I've got a material overlaying everything that affects the coloration of all of it. There are other ways to do something that's more like an actual LUT in both Meta and Effect House. Segmentation holder for the user. Standard, just making sure that you're cut out from the background. And the background holder. So we have a day and a night, and we're just toggling in the node graph the visibility of one or the other. Most of these are just visibility toggles, as you'll see in the node graph. We do have a few sound effects. We have a kind of a droning, always on background loop. We have the audio for when you transform and the audio for when you detransform. And some of the logic that you'll see has to do with controlling when those play and making sure that they play at the correct time and don't overlap each other. And in this effect, there's not too much to call out actually in the property sections of any of these things. You'll just see if you select them that position rotation of the eyes is controlled in the node graph. They're all using pretty standard material things that you'll see over here in the assets panel, which we'll go to now. Clean up my view a little bit and give us some space. The head occluder, again, this is just to make sure that all the transparency is working correctly and that we're not cutting through things with our text materials. The eyeball is a 3D object that applies during the daytime scene that those color shaders are applied to, and we'll look at that in the node graph. Face deform, so if you had a deformed model from a standard face, that's what this is referring to, and in the Metaspark Studio, this particular effect, it's not as pronounced, but you'll see a bigger example of that in the Effect House template. So those are the special assets. And in the materials, pretty self-explanatory. I like to type MAT underscore, then the name of the material as a shorthand for material, so that when I am expanded out like this, I can quickly look and know right away I'm looking at a material, not a texture or some other thing. It can just be visually confusing for me when these effects get big. So I adopt certain kinds of naming conventions for that, but you do not have to. Not too much to say here. You'll see how this all plays in when we get into our node graph. We've got our main images, background day, background night. These are just textures you'll see here. The skin smoothing texture came in automatically. This is default Metaspark Studio stuff that's provided to you and that you can mess with in an image editing program. Face blush, which you're welcome to use this as a template for your own stuff if you'd like. Bringing that into Photoshop or GIMP or any of those image editors and using this as a base template will give you something that's more or less correct for a large variety of faces. Gloss, iris, this is what's getting applied in the daytime part. Our background image for day and night. Our face diamond. The spacing of this is good as a template if you like this, and you could adjust relative. So we've got some texture sequences here. Okay. Eyeball shader. This is a Spark AR library built-in patch. Not built-in, but I imported it from the Spark AR library. And we'll show that. These are M4As for all the sound effects, and in the PDF or on the site or both, I'll list the encoding settings that you need to use to make an M4A for this. Our actual playback controllers here for our audio. So we have shaders here. You can ignore this if you want. These are things that are brought in automatically, and you do not have to touch them to adjust your effect. So let's jump into the node graph. All right, the node graph. So on a complication level, I would say this is somewhere between the randomizer and the emitter. It's not the most complicated thing, even though we're looking at a bit of a spaghetti mess right here. But we'll walk through it all, and it's pretty straightforward once you get the hang of it. Zooming in here, instructions. So if you're not already aware, for instructions, if you want the user to interact with your effect in some way, there's several options that Metaspark Studio gives you right away that don't require you to have to add any of your own language to the opening of that effect. And you can start it by just having a pulse patch enabled. When you have that, then when the effect starts, it should just pulse immediately and show that timed instruction. Otherwise, you could do something like get a runtime node and then like a greater than or equal to 0 and then pulse that. And that would force it to work as well. So as for these options, for any of the timed instructions options, this timed instruction is a native node, native patch. You go into your project capabilities. Oops, is the wrong place there. in project properties, in capabilities, and then when you add a timed instruction node, you'll get an option there in instructions and custom instructions, and you can add that as you like. And you could actually add multiple instructions if you wanted. I wouldn't recommend it, but that also provides you with a token there, and that's what this is referencing. Blink your eyes, blink your eyes. So you'll get this instructions automatically in the capability, and then you drill in with this and choose from their options what a user might want to do to interact with your effect. It's a good practice for UX just to, if it's not clear right away when an effect opens how you interact with it, it's a good practice to have this. And Effect Apps has something similar as well. In this case, it goes for 2 seconds. And nothing needs to happen after that. Instructions kind of operate in their own little world. Nothing else is tied to it. Face Finder. So this is a native patch, and coming out of it, you can either count the number of faces coming out of it or directly operate on a particular face it sees. Now you'll see right here in Face Select it says index 0. But you're not interacting with 0 faces, you're looking for that first face it sees. So what gives right here? Well, if you're not already familiar, Spark and Effect House both understand lists of objects as being part of like an array. So if it sees many faces, that's basically a list of like, 1 face, 2 face, 3 face, 4 face, like a list of faces. And in programming speak, the first element of a list of elements is the 0th element, or the not element. So a little bit of subtraction you do in your head. The first element that it's looking for will actually be 0. So in a list of 5 elements, it's actually 0, 1, 2, 3, 4, instead of 1, 2, 3, 4, 5 elements in a grouping. Okay, it's a little funky, but you get used to thinking that way. So it sees the first face, and then when it sees the first face, a couple of major things happen. Eyes, this is a built-in node available to you. Eyes of that face, we don't care in this case about the 3D rotation, scale, or position of what it's seeing, but we do care about the face itself, and we see, just following this pipe or connection up, that there is an eyeball patch. So the eyeball in that face for both eyes, there are some relative points there that it's always tracking when it sees it. And we take advantage of that to do a couple of things here. The values that come out of these points are vector 3 values, and that means they are values that are like an array of 3 different categories, in this case X, Y, and Z. To show that a little bit, yeah, this will do. You see right here, this is the Y axis, that is the X axis, and this is the Z axis. Z meaning towards, far and away from you. Towards you and away from you. Y is up and down, X left and right. Different programming platforms and languages sometimes treat that differently or use different terms for that, but in MetaSpark Studio, it's an XYZ. You'll see it referred to as vector 3 sometimes, and that's where you can see that's where that type of node is. It can be other things, but you only need the X, Y, and Z to be able to track accurately to the person. So in the case of this left eyeball center, we have a few values being tracked. And to get those values out of that vector 3, we unpack them in MetaSpark Studio. That's the term used. Okay. So you see, right, the outputs of that are X, Y, and Z. So now we can look just at the X value and do things to them. Likewise with Y and Z, which we don't actually need to mess with. We want it to perfectly track to the Z value of the user so that when they come towards and away from us, that's tracked without any modification. Likewise up and down. Both left and right, we need a little bit of adjustment. because this is a special element that doesn't conform perfectly to the eye. It's a layer right on top of it. So we actually do a little bit of an offset, which is what the subtract node does on the x-axis. It's always offsetting just slightly to cover this space so that the center of this actually is probably not quite the center of your iris, the center position of your eye. It's a little bit offset. Then we pack them back into that vector 3, and that is what natively connects to the 3D position of the glow. So that's how we're creating the slight offset for the glowing eyes. Same thing's happening here. For the rotation, though, we're rotating around the y-axis, 180, which is a flip. When we're rotating, we're dealing with the 1 through 360 degrees. We are rotating this 180 degrees so that it's actually the correct orientation on the eye. If we look at the glowing eye, its asset itself, we can see because the asset for the glow is actually just for one eye shape, and we're just flipping it so that we're saving our size. We're only using one animated sequence and just transforming it dynamically in the node here to make it look like we have two. We also see that we are just making sure that we haven't lost the colors that we're using for the iris. So even whether it's day or night, whether the eyes are glowing or we're just looking at the iris color, let's see if we can bring that back here. Got a green. So okay, that's just a one-to-one track from the information coming out of here to these. So these are basically always on and always doing calculations, but we're just toggling the visibility of what is available at what time. If you've blinked at a certain point, you get the eye glows, and if you have blinked at another point, you're getting just the iris coloration, and it's just a visibility toggle. You see here we have a little bit of our adjustments for the left eye as well when that's on. Same thing, just tied to the particular eye. And you'll see that we're tracking the right eyeball center, right eyeball rotation. You say left eye glow. That's because of the orientation of the asset itself, and also Spark's definition for what is the left and the right versus my own. How I think about it when I look at it. Am I looking at the actual left eye or the left eye from my perspective? So that can be a little bit confusing there. Apologies there. We also see from this eye, this face, when it's closed, we are controlling that visibility I just mentioned for the glow. And importantly, we're using the not patch so that it negates the state of the visibility based on where we're at. Play this real quick. Oop. So right now, they have their visibility toggled on. And when you saw that flash, it toggled it off. We also see, carrying along the face data, when the openness is at a certain point, there's a slight bit of math happening here to all of the values that are being put into the head occluder. That is because if I didn't dynamically adjust the scale of the occluder, you could start to notice some weird clipping happening with the textures and materials on the face. So it's that balancing act when you have segmentation and multiple effects layered onto each other, on faces in particular, that you might need to do some dynamic adjustment to create a good use case scenario where as many people as possible will be able to use these effects without weird visual elements happening. And part of how you can do it is by adjusting the scaling of the elements that you're using to hide and clip out textural elements. I hope I said that well. But in this case, what's happening is that when the mouth opens a little bit, if I wasn't doing this math on the occluder, it would just not look right. Backtracking just a second here. Just a note that you can use the face finder multiple times, still referencing the same face, and it can be a way to kind of keep your organization, which can be tough to hold on to when you're dealing with node graphs. It gets complicated quickly visually, and this is an option you can do that I haven't found to be very impactful for performance. So even though we are doing a bunch of things on a particular face, and you could just do this here, or come out of this here to this, I've kept this intentional sort of segregation where I'm just looking at what's happening with the left and right eye in the daytime. These are the non-glowing eyes where I'm just keeping things tied together there. Specifically the iris. Sorry, and just to be clear about something, these guys, these eyes, are the daytime eyes, and that's what that's tracking and keeping a hold of. And this is here mostly in case I wanted to do something special by unpacking and repacking values like you saw previously. And to that end, these are the positional tracking elements for the glowing eyes. And here we are in our blink section. So what all this ultimately is doing is just controlling the visibility of all these items once you blink. We've got our blink coming from the face. Blink is a built-in node in Meta. And then we are going to blink on and off certain things. So we have our switch here to help us toggle automatically on and off. We have a negation node here, a not node, I should say. That'll give us the reverse. So when certain eyes are on, the other eye is off. We also get a pulse out here that gives us on and off pulses. And pulse values, they do flow from each other. In other words, like the turn off pulse from here, when it hits here, this pulse, even though it doesn't have an off input, it knows that this is an off. It knows that there's going to be an off value being output from it, that's going to flow through it. It's going to turn on a transformation audio file. And when that pulses, we're also going to get a couple of different things happening here. And when we turn off, we're going to get our detransformation audio. So this is just audio controls that this pulse is controlling right there. Just the visibility of the eyes here. And we have an if then else. So what this gives us is that when we get that blink, we're going to pulse and it's going to hit that switch. And when that blink is either blinking on or off, either way, we're going to get a turn on or turn off pulse respectively, and then turn on or turn off the visibility for all of these elements, just visibility. And then you see I kept it here because it's all happening during the blink and is relevant to the eyes, but it's not actually connected to anything. And that is the built-in shader, the built-in eyeball shader that came from the Spark AR library. These are free assets, and you see it's right there. Select that, import it. It shows up right here in your patches. You can just drag it over, which is what I did. I chose some purpley colors, kind of keeping with this theme visually. And you have a few options here to explore and play with. And you just want to make sure that your output from this goes to the texture you are trying to control. In my case, the material for the eye color. And that's it. So there's not, functionally, it's not that complicated. There's not too much going on. You're just making sure that the positional values of your eyes are tied in and relative to the effects and planes that you're using. And the only real weird gotcha that you might need is almost a troubleshooting step, is that we have this occlusion handler here, which you can play with to see what it's really doing. By really overscaling the occluder, you'll see what happens to the elements here. But it's a troubleshooting step. When you start to notice funky things with facial meshes and makeup and stuff like that, adjusting your face mesh occluder with scaling dynamically based on what you're doing can kind of solve some of those problems and get around it sometimes. So that's it for this one. Now I'm going to jump over and show the Effect House template.